Hey guys, so I'm making videos for you all to help you out with the rest of the semester. We are working on the 4-2 graphing simple rational functions, which I labeled up here. I really hope that you are listening. You are going to put these notes in your spirals, which what we do here will be on anchor charts for you guys to take pictures of, take them back to your desk, write them in your spiral so that you have notes so you're able to use them for your test. Also, just so you know, FYI, Ms. Blake and I came in during our spring break to make these videos, so I really hope you guys actually pay attention, do the work. It should, you know me, step by step, so everything's done step by step, and so let's go ahead and get started. So the first thing about this is, what is a rational function? It's written in the form of f of x equals a divided by x minus h plus k. All right, notice how we've been using hk. That's something you should already be familiar with. We've been using that since quadratics. And then also let's talk about their domain and range of a rational function. So the domain is always going to be written in this form. And it reads, all values of x such that x is not equal to h. And the range is the same thing as domain. The only difference is it has the y values. And it would say all values of y such that y is not equal to k. The next thing that we're going to talk about are their asymptotes. And what are asymptotes? We have both vertical and horizontal, and those are just imaginary lines that a function approaches but never crosses. For example, if I were to give you guys an exponential function, where an exponential function does this, this would be a vertical asymptote. This function would never cross the dotted line.
Horizontal, not vertical.
Yeah, I'm sorry, this is your horizontal, not vertical. I was trying to think about the y, thank you so much. But yeah, and I know I was too busy paying attention at how wonky my dash line looks too. It looks like a wave, but you get the picture. This exponential function will never cross the horizontal asymptote, but it does get close to it. Okay, so we are going to move along. Now we talked about really quick, now that we talked about the attributes, the key features in regarding to rational functions, let's go ahead and take a look at letter I. So we're going to move along over here. Can we see me? Yes, we're good? All right, everybody ready? Yes? Yeah.
Yeah, there we go.
There we go. Okay, so we have f of x is equal to 1 divided by x minus 6 minus 5. Now, just based off of what we did on the front part, if you look right here where it says rational functions, all right, we're gonna match those letters. Those letters right here, these variables, not letters, the variables will match to the values that we have right here. So in this case up here, in this top, we know that this is a, we know that this is h, and we know that this is k. All right, so when I talk about my vertical asymptote, and notice I just put v dot a, that's just vertical asymptote. When I talk about my vertical asymptote, you go back to your notes and you go to the table and you look for the word vertical asymptote. And as you can see the vertical asymptote, can you see it from here, from the screen? Can they see it? Yeah? All right, so if you can see it, it says x equals h. Remember what I've told you before. If it says x minus, h is positive. If it says x plus, h is negative. So don't forget that. So in this case, this says x minus h, so h would equal to positive 6. So x equals to 6. All right, the next thing we want to do is find our horizontal asymptote, and the horizontal asymptote is the k value. Now don't forget that you have to take the sign with it. So if it says minus 5, then y is going to equal to negative 5. So far, so good. Okay. Now, the next thing that we're going to do is we are going to copy the domain exactly the way we have it written up here. And as you guys go through here to your, right here where it says in the top left, the top right of your table, it talks about your domain. You're going to copy it exactly how you see it. The only difference is instead of using the letter h, you are going to replace it with the value that you have for your vertical asymptote. So we are going to say all values of x, which is this, such that x is not equal to 6. such that x is not equal to 6. Don't forget to put that not equal to sign. And the range, we do the same thing for the range that we did for the domain. The only difference is we use the horizontal asymptote. And we do all values of y such that y is not equal to negative 5. Okay, so the next thing that we want to do, the next thing that we want to do is, so really quick before I move forward, I just want you to see that this 6 went right here, okay? And then the negative 5 came from the horizontal asymptote. Okay. All right, why is it that it's not equal to 6 and why is it not equal to 5? Because those are, again, our imaginary dotted lines. So at 6, negative 5, you have dashed lines this way, okay? And your hyperbolas will approach them in this way. And I know it's kind of difficult to visually see it. And I can draw it for you real quick, just so you can see what I'm talking about. Basically, all it's telling you, and excuse me with my, let's see, 6, negative 5, 1, 2, 3, 4, 5, 6. Negative 5, 1, 2, 3, 4, 5. Okay, so all it's telling you is you're going this way and you're going this way. You're not approaching it, you're just getting close to it. Sorry that my right here it's a little wonky, my bad. But that is what this is right here. All right? Okay, so now that we did letter I and we kind of worked it out a little bit more, let's go ahead and move on to 2i. So let's go ahead and go to 2i where it says y f of x is equal to 1 divided by x plus 4 plus 1. So we want to identify our h and k. Remember, and recall what I've told you that, whoa, good catch. Recall what I've told you that if this says a plus, this plus sign means h is negative.
And I'm going to interject with my voice here for my students because I will also be putting these videos on my Google Classroom. Remember, H is kind of like the middle child. It doesn't do what it's supposed to do, so it does the opposite of what it says. Okay? And K is your oldest child who always does what is told of them, so they will follow their sign. But H is a middle child. They do not follow their sign.
See? So far, so good? All right. So we go ahead and we write out what our vertical asymptote is. Since I said H is positive, we go ahead and say that x is equal to negative 4. So far, x is equal to negative 4. And I'm going to go ahead and underline this so that you could see what we're talking, so we can see where everything is going to go next. And then the next thing we want to do is go ahead and get our horizontal asymptote, which is x is equal to, oops, did not want to write it in green yet. Where x is equal to,
Y.
because I'm going to change the domain and I'm going to use my colors.
Y. But it's Y, not X.
Oh, sorry, it's y. My bad. Sorry, guys.
It's been a long spring break, ladies and gentlemen.
It's my spring break, and it's our spring break, and we're here. Which I do not regret. I'm doing this because I adore you all, and I want you all to be successful, and I know you all are slacking it, so I need you all to get back to where you were at, okay? So, y is equal to positive 1. That was directed to my Algebra 2 classes, not Miss Blake's class, just so y'all know.
But we love you all.
Yes. Okay, so the next thing I want to do is I'm going to go ahead and write the domain and range. Again, I'm just recopying everything as it goes. So x, all values of x such that x is not equal to negative 4. And range is all values of y such that y is not equal to 1. Okay? And again, just so you guys see, who gets this? Domain gets the vertical asymptote, h, and the range gets the horizontal asymptote value. So just so you guys can see where the numbers come from, okay? So next, we are going to do one more problem because there are a total of 6, and I figure if I can knock these 3 out, you should be able to do the other 3 examples on your own. So we're going to go ahead and do 6i, well 6, not 6, Roman numeral 6 is what I want us to do. So go ahead and go to Roman numeral 6, that is the very last one, and that is that y is equal to -1 divided by x plus 7. Now there's a reason why I chose this one for y'all to see, is because if you go back to the rational function form, the way it's written as, if you go back to it and you look underneath in the denominator for a, it says x minus h. So our vertical asymptote is h, right? Do I have an x minus h here? You all should have responded no. No, you don't. So because you do not have an x minus h, you will let x equal to 0. Because, and I'm going to go ahead and put a side note here, because there is no h. And then our horizontal asymptote is a +7, so y is equal to +7. And if I move a little too quickly, you can always, pause and slow down and do what you got to do to kind of go over everything again. Yeah. So basically, yeah, that's what I wanted to tell you. So your domain, of course, you rewrite it. Notice the trend, guys. We rewrite everything. Everything is the same. The only difference that we're doing is we're changing the values for h and k. Your domain and range is super simple the way you're writing it. You just have to change the values, the h and k values, once you figure out what they are for each function. So your domain is all values of x such that x is not equal to 0. And your range is all values of y such that y is not equal to 7. Okay. And let me see. That is what we've done so far for the first page. What we're going to go to do is we're going to stop this video so I can go ahead and set up to get the second page done. And we are going to go ahead and flip over to the next page, which is writing the function in the form of f of x equals a divided by x minus h plus k by using a graph. So we're going to go ahead and take a quick stop. Let me go ahead and set the board up and I'll be right back.